Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering, and you know that we are talking about the various surface modification techniques, and among the various surface modification techniques, especially we are talking about the techniques which are associated with the modification of the composition of the surface and near surface layers, so that the required improvement in surface properties can be achieved for improving the tribological behavior of the functional surfaces. So, under this category now we are talking about the two processes. One is the ion implantation and the second is the ion plating. So, I will be taking up first of all the ion implantation. So, the technique which is used to modify the surface properties by modifying the chemical composition is ion implantation. Initially, we will talk about the basic principle related with this process. So, you know that the surface properties are affected by the microstructure of the material, which includes the kind of the phases which are there and the crystal structure of the material itself. So, we know that most of the metals have the crystalline structure, and this crystalline structure may be like the BCC or FCC, HCP, or like BCT type, or like simple cubical structure. So, and according to these structures, the various metals offer the different category of the properties, different types of the properties. For example, the metals having the HCP crystal structure offer the low ductility and higher brittleness. On the other hand, BCC offers the high hardness and strength. SCC metals are comparatively soft, they are of the low strength. So, like iron is having the BCC crystal structure, aluminum, silver, etc. have the FCC structure, zinc is having the HCP structure, BCT structure is found, body centered tetragonal structure is found in the like martensite is a typical phase which is found in the steels. So, according to for a given composition or for a given metal, if there can be various crystal structures, especially in case of the like allotropic materials, like iron we can have in form of BCC crystal structure or FCC crystal structure or even BCT also. So, according to the crystal structure, properties are significantly influenced. So, in this approach, what one thing which is used to alter the surface property is to modify the crystal structure, and this modification basically is in form of completely damaging the crystal structure and making the crystal structure completely amorphous. So, there is no systematic arrangement of the various atoms like in typical crystalline materials. So, this is one aspect, that the crystal structure of the material is damaged and it is made the amorphous. And another aspect related with the surface properties is the kind of phases which are there. There can be like iron carbide or iron nitride, there can be like the martensite or various other kind of the intermetallic compounds which can be present at the surface. So, in this approach in this technique, the another thing which is achieved is the formation of the typical compounds and phases which will help to improve the properties with the help of the ions of the suitable elements. So like if the nitrogen ions are used, then nitrogen will be getting introduced at the surface of the metal, and this will be reacting with the metal to form the corresponding nitride, and which will help to improve the properties. So in ion implantation, basically there are ion implantation, basically there are two mechanisms which are exploited to improve the properties. One is making the crystal structure amorphous, or forming the required phases and compounds by introducing the suitable elements like nitrogen. So formation of the iron nitride is typically achieved when the nitrogen ion implantation is performed, and the damaging the crystal structure is helps in achieving the amorphous structure at the surface. And so these are basically two main lines or two main mechanisms which help in improving the hardness, so improving the wear resistance. So how it is realized, basically we use the high energy ions or ion beam, which is directed onto the surface of the material which is to be modified. So the impact of these high energy ions with the surface will be modifying or damaging the crystal structure of the metal, especially at the near surface layers. So there will be various zones which will be formed, like say this is the typical arrangement of the atoms in any metal. So up to certain depth we will see that the atomic arrangement has been completely displaced, damaged, and this will be leading to the, and this damage happens primarily due to the impact of these high energy ions with the substrate, and this damage will be leading to the production of the amorphous structure. At the same time, these ions of a particular element like nitrogen, when they get introduced in the metal, these will be interacting with the substrate material to form their respective compounds. So now we will see in this situation that obviously the concentration of that particular element, ions of that particular element will be more near the surface layers, and that concentration will keep on decreasing, and far at a significant depth from the surface there won't be any change in the crystal structure as well as any change in the chemical composition. So this is how we will be modifying the surface and near surface layers characteristics by changing or damaging the crystal structure, and by changing the composition by introducing the elements of particular elements. Nitrogen is one of the commonly used gas for introducing the nitrogen ions in the metal, which can which after reaction with the iron especially forms the iron nitrides to improve the surface properties. So the sequence of this process works in like this: impact of the high energy ions with the substrate. This substrate damages the lattice structure, leading to the formation of the amorphous structure, at the same time introducing the ions ions of particular element which react with the substrate to forming the compounds and the phases, and these formation of these compounds and phases will be leading to the improvement in properties. There is one specific thing which is to mention is that this damaging the lattice structure leads to the formation of the dislocation. So, dislocation density is increased in very controlled way through the impact of these high energy ions. So, basically development of the damaged lattice structure coupled with the controlled increase in the dislocation density, formation of the compounds or the phases which will help to improve the properties. These phases can be stable type or unstable type, means which will be modifying their characteristic and nature as a function of time and with the change of the conditions which for which these will be exposed. And when these changes in terms of the formation of the compounds, dislocation density and the formation of the amorphous structure. These combination of these three changes, especially at the near surface layers, leads to the significant improvement in properties with regard to the hardness. Increase in hardness increases the wear resistance, and this increase in wear resistance is also coupled with the increase of corrosion resistance. So, the mostly this kind of the improvement is achieved in case of the steel components. Now, what are the conditions which are required for improving the properties and how do we get this? So, say there is a setup for producing the iron beam. So, like iron forming gas, mostly it is nitrogen or argon, it can be, it is introduced, and this will be leading to the formation of the ions which will be directed at a high speed towards the surface of the component which is to be modified. So, when these ions impact with the surface, these will be leading to the various favorable effects, like impurities present at the surface are cleaned automatically during the processing, and apart from cleaning, this will be leading to the introducing the ions of that particular element, like nitrogen. For nitrogen ion implantation, it will be damaging the lattice structure and forming the amorphous structure at the near surface layers, and these ions which are formed, these are accelerated towards the substrate using the suitable electrostatic field, so that they can achieve the required energy for damaging the crystal structure and introducing the ions at the surface. As far as typical values are concerned, for achieving this kind of the effects, about 1% of the ions are needed to modify the surface properties, wherein the ion density 10 to the power 18 to 10 to the power 21. number of ions forming about 1% up to the depth where up to which the property improvement is required, and this is like 10 to the power 18 to 10 to the power 20 one number of ions per meter square is required, and approximate 1% of ions will be needed to have these favorable changes at the surface layers. But the capability of the process to alter the crystal structure and to achieve the required dislocation density as well as forming the required phases and compound, this depth is very limited up to the 1 micrometer, means this process and implantation can be used to improve the surface properties up to the depth of 1 micrometer. So, the depth which can be modified by this process is very limited. As far as advantages of this process is concerned, this process results in very low, means the ion implantation is performed, the temperature of the substrate is very low. So, the low temperature of the substrate or the workpiece. So, there are number of benefits associated with this, like very less or the no geometrical modification, which means there is no distortion, there is no dimensional change, because there is no major rise in temperature of the workpiece. So, the no dimensional change, and due to the limited temperature rise, there is no unfavorable metallurgical transformation. There is no unfavorable metallurgical transformation and therefore no compromise in terms of the bulk material properties of the substrate or of the component. So, we have seen that those high temperature processes like carburizing or cyaniding, where too high temperatures are used, we experience lot of undesirable effects in terms of the distortion or the dimensional changes, unfavorable metallurgical transformation in the base metal, leading to the compromise with regard to the or mechanical properties of the component. At the same time, this process also can be applied very selectively. So, very selective surface areas can be modified. So, whatever the small or the large functional areas are there which can be modified, those can be modified very effectively in very selective manner. And the another important aspect that the inherent cleaning is involved. So, inherent cleaning of the surface, and so even the cleaning of the surface is not very crucial or critical in this case, because bombardment of the ions at the surface performs the automatic cleaning of the surface. So, these are some of the benefits of the ion implantation. Only limitations, there are a number of limitations or the disadvantages associated with this process, and those disadvantages are like we need really very expertise to handle to design the surface modification. So, skilled worker or expertise is needed to implement the ion implantation in order to realize the surface properties as per the requirement. Another aspect is the limited depth of surface modification. As we have seen that normally the process is limited up to the 1 micrometer depth. So, those applications where we really need very thick modified surface layers and hard surface layers of greater thicknesses, there this process can not be used. So, limited depth of modification limits its applications, because all those applications where very high resistors will be acting, where limited depth of surface modification may not be good enough for improving the performance of the component for longer time. Under those conditions, the ion implantation technique may not be good. Then the surface modification can be done only those areas which are in direct line of sight of the beam. So, surface modification of those areas which are in direct line of sight can be done. Means all those areas having the inaccessibility issues and not in direct line of sight of the ion beam source, those cannot be modified using this process. So, inaccessibility of the surfaces can be issue or the one limitation as far as the areas which can be modified using this process. And one more disadvantage associated with this is that we need really high vacuum. So, whenever vacuum is there, we need to perform extra work to modify the we need to perform the extra work to achieve the required vacuum, and this in turn requires the vacuum chamber, vacuum pumps, and these in turn will be increasing the cost of the equipment as a whole. So, these are some of the undesirable sides related with the ion implantation. Now, we will be talking about the ion plating. In case of the ion plating is a very simple process. In this case, we use a chamber with the vacuum pump. To create the vacuum in the chamber like this, and one side we have the crucible for evaporating the metal to be deposited like this. So, heating is done using suitable heating source, and this is the coating material which is melted, and then it will be coming out in form of the metal vapors. These metal vapors are ionized using suitable electromagnetic fields or developing the suitable conditions. So, ionized metal vapors are used, and these ionized metal vapors will be directed towards the surface of the substrate, where they will get deposited on the surface of the substrate. So, here this high energy ions of the metals are deposited on the surface of the substrate, but to give the enough energy to these ions of the metal vapors, basically the high temperature conditions are used, and which are unfavorable, especially with regard to the substrate performance or from the substrate properties. So, in this case, ionization of the metal vapors from the required coating material, and these ionized metal vapors are accelerated towards the substrate using the suitable potential difference, or so suitable heat, so a suitable source or the potential difference is established between the two, so that the ionized metal vapors can be accelerated towards the substrate with the sufficient energy, and their impact with the substrate will be leading to the deposition of these ions of the metal vapors with the substrate. So, this is how it is, very simple one, but there are some of the issues like there can be metallurgical issues with regard to this kind of the deposition or plating, where ions are plated or deposited on the surface of the substrate. So, if there is a large difference in the thermal expansion coefficient of the substrate and the material which is being plated, then it can lead to the peeling off or spalling kind of the situation from the substrate material. So, this causes the poor poor bonding situation between the plating or the plate or the coating which is being applied and the substrate, and this is one issue related with this process, and this also leads to the very sharp interface between the plating layer and the substrate. So, if that the sharp interface if being formed due to the metallurgical incompatibility, it will be leading to the problem of the poor bonding and the delamination or the peeling off kind of a situation will be leading to the easy removal of the material which is being applied on the substrate. So, this is a negative side as far as the ion plating is concerned. So, there are other modifications related with this process. If they are applied, then the bonding can be improved, and in that category basically we have ion beam assisted vapor deposition or ion beam assisted sputtering. These are the two other techniques where again the required element at the surface is deposited, and then the required bonding is ensured through the bombardment of the ion beams at the material which is deposited, so that it forms very good metallurgical bond with the substrate and the bond strength is improved. At the same time, a very good intermixing with the substrate is also facilitated. So, now I will summarize this presentation. In this presentation, basically I have talked about the ion implantation and the ion plating kind of the techniques, and we have seen that in case of the ion implantation, it is the damaging the crystal structure, developing the required dislocation density and forming the required phases at the surface helps to improve the hardness and the wear resistance using the ions of the nitrogen or the argon. While in case of the ion plating, metal vapors are ionized and those are deposited onto the substrate. However, in this case the bonding between the plating or the coating which is applied and bonding between the coating and the substrate is poor because of the sharp interface which is formed, and this can lead to the metallurgical incompatibility, especially when the two metals are completely different in terms of the metallurgical properties or in terms of the thermal expansion coefficient. So, if the properties are too different, expansion coefficient is too different, then it will be leading to the spalling or peeling off or delamination of the coating during the service because of the poor bonding. Thank you for your attention.